Okay, everybody, hello. I'm going to go ahead and start you off on this lesson. Today we're going to start talking about operations with functions, and we're going to start with an easy one, which is all about adding and subtracting functions. Okay, let's get started here. The first example right here, we're going to look at function addition. And function addition, if you guys are looking at this problem right here is really where you want to kind of focus your attention first. I know there's not a ton going on here, but you'll just notice there's a plus sign between these two functions. Now what this is basically telling us is you want to add So what this is basically saying that you just want to add the f function with the g function. And up here, you'll notice, okay, we have our f function. Our f function is 3x squared plus 2x minus 1. And then we also have our g function. And notice we're just finding the sum of the f of x function with the g of x function. Now sometimes we've got to be on the lookout for this because I think I have an example like this, but you might want to be on the lookout. It might say add the f of 4 function plus the f plus the g of negative 2. Something like that, which just means you're going to evaluate, which is what we did previously. You're going to evaluate those numbers into the functions and then add or subtract them depending on what the operation is telling you to do. So let's get down to it here. So the f function is just 3x squared plus 2x minus 1. And I mean, if you want to use parentheses, you can. Actually, it's not a bad idea to use parentheses because going into subtraction, it's going to make more sense. And then we're going to add the g function, which is x squared plus 2x plus 5, both of which are quadratic functions, but that doesn't really matter right now. And now what you're going to do is you're going to just basically combine like terms, and that's it. You just got to put like terms together as much as possible. So the x squared terms make 4x squared. The x terms, they are going to make 4. And the constants, negative 1 and 5, are going to make 4. So a bunch of 4s there. And there you have it. So the notation, I guess, if you want to write it like this, and I don't think you're going to have to do this on IXL. You don't have to write the f of x plus g of x equals. But the answer, or the simplified answer, is 4x squared plus 4 plus, oh, I forgot an x. So yeah, 4x squared plus 4x plus 4. All right, moving on to subtraction. Now subtraction functions, the thing you have to remember, and this is something that I've mentioned quite a bit when we have been in class at least, is that when there's subtraction there, we definitely have to think. We definitely have to think about what does that subtraction or what does that minus sign do, especially to what it precedes. So that minus sign is right in front of that g of x function, which means it's going to affect that entire g of x function. So the f of x is 3x squared plus 2x minus 1. And then I'm going to put that in parentheses. And then minus the g function, which is x squared plus 2x plus 5. And really the only thing that kind of separates this problem from the one we just did is that this minus sign right here affects the entire expression, or in this case, this is a function. It affects an entire function that's in front of it. So if you just stick the minus sign in front of the first term, well, then you're not doing enough with it. This minus sign affects the entire thing that it's in front of. So I'm going to leave the first function alone. It doesn't work backwards, you know that. And then we're going to distribute the negative into x squared, which makes minus 1x squared. We're going to distribute the negative into plus 2x, which makes minus 2x. And same thing for the 5. Plus 5 turns into minus 5. And now we're going to just put like terms together as much as possible. And this result should come out differently. The x squares are going to make 2x squared. 2x minus 2x, well, those are additive inverse of each other, so those cancel each other out. they're gone. And then the constants make minus 6. And that's it. That's all you can do. So that's that problem. So like I said, with these kind of problems, we just want to kind of keep in mind that when you have a minus sign that's in front of an entire expression, that minus sign needs to be distributed. And that's something that we've discussed quite a bit. That's something that kind of crops up on us quite a bit in algebra, and it's you're not going to be done with it after this class as well. Now the next example on the other side of your guided notes is we have just basically the same thing. We have addition here. We have addition, but the only thing that's a little bit different, this doesn't just say f of x plus g of x. It says f of 2 plus g of 2. So if you wanted to, one thing I've had people do, and it really doesn't matter, you could just leave them as f of x plus g of x and just put those together if you want. Both the x terms, we have a 2 there. So we could get away with that, but we don't have to. So what we want to do here is we want to take the f function of 2 plus the g function of 2 and add them up. The f function of 2 is going to be just the f function, except we're going to put a 2 in place of the x. And then the g function of 2, again, we're going to put the 2 in for the x, and then we're just going to solve accordingly. So if we handle that, that's 4 plus 4. That is going to be 4 plus 1. 4 plus 4 is 8. 4 plus 1 is 5. And there you have it. Now that looks more like a solution. A lot of times in algebra we get answers that look like another math problem. It looks like we have some more work that we have to do. But this one, in fact, looks like an actual solution to something. Okay, now in the next example here, we're just looking at the generic x function. What we're doing for this one right here is we're taking f of x and we're subtracting the g of x function from it. And just like we did on the previous page, we want to make sure that we distribute that negative into the entire function of g. So the f function is just x squared plus 4. And we're going to subtract the g function, which is going to be x squared plus 1. Now the minus sign that's in front of that function affects everything, not just what's close to it, but it affects everything in that function itself. So I'm going to leave the first function alone. I'm going to distribute the negative into the second function. Now, if I look at like terms at this point, you'll notice that the squares, the x squares, they cancel each other out. But the constants do not. And you got 4 minus 1, which is 3. Okay, now for the last example, let's see what happens with this. Now we're taking basically the same setup here. We're taking the f function and we're subtracting the g function. But this time we're doing the f of 2 and subtracting the g of 2. So the f of 2 is going to be set up like this, minus, and we're going to put the number 2 in the place of x. Now notice I didn't do any distributing yet because there was some arithmetic that we needed to do inside the grouping symbols there first, so that was important. All right, so 4 plus 4 is 8. 4 plus 1 is 5. We have the minus sign there. And then we're going to attach that to the 5. And then notice this for this problem, we ended up with the same result. So you ended up with 3. That does it for your lesson right there. These were pretty straightforward, I would say. One thing I didn't go over was an example like, let's say everything canceled out. Let's say the x's canceled out, the x squares canceled out, the constants canceled out. Well, that doesn't mean there's no solution. You can just put 0. As you know, 0 is sometimes, or a lot of times, is going to be a solution to a problem. That's going to happen, and that's okay. All right, so that does it, everybody. Your lesson was pretty easy. If it was tough for you, let me know, and I can help you out. Make sure you guys do the IXL, and this time today on your IXL, I want you guys to get to 90 or better. So get better, I usually say 80, But today, I'm going to say 90 or better. I notice a lot of you actually get to 100, which is great. You don't actually have to do that. I think some people find it really frustrating when they end up having to, they get to those challenges. I think they call it the challenge zone in iExcel. And once you miss a problem, it takes you all the way back down to like 80 something or 70 something. I forget. It's a little bit weird, but it's not my fault. It's not my program, but sometimes it does that. So if you want to get to 100, that's fine. But I would say today, get a score of 90 or better, and that should do it. All right. So everyone have a great day. Keep safe and take it easy.